Okay, so we at this point should have already watched the 7.3 day 1 videos. So this is the homework assignment for the 7.3 day 1. Now, I already spent part of the video from this task giving you directions on how to complete the homework. So we're going to go ahead and start with number 1. Number 1 was a vocabulary question. It said 2 events are blank if the occurrence of one event does not affect the probability of the other event. So you should have put independent. Number 2 and number 3 are both independent events, so we're just going to multiply their probabilities together. Number 2 says, what is the probability of rolling a 1 and then another 1 when a number cube is rolled twice? So what's the probability of rolling a 1 and then a 1 again? Well, there's number 1 on a traditional 6-sided die. So both of these probabilities are going to be 1/6, which means that when you multiply, you end up with 1 over 36. Number 3, we have a coin landing heads up on every toss when it's tossed 3 times. So that's the probability of heads times probability of heads times probability of heads, because we want to get that face of the coin 3 times. So that would be 1/2 times 1/2 times 1/2, or 1/8. Number 4, it says that the blue, I'm going to read this part first. We have 2 number cubes that are rolled, 1 blue and 1 yellow. Explain why the events are dependent, then find the indicated probability. So I'm just going to talk about why they're dependent. Number 4 says the blue cube shows a 4 and the product is less than 20. So we want both of these things to be occurring at the same time because we're rolling these die at the same time, and we want this to happen. So for 4 and 5, you should have used this table that I gave you on the notes that we did from 7.3 day 1. If you have that, go ahead and pull that out, or just pay attention to mine as I go through these problems, okay? And I'm going to write all over mine just because that helps me visualize. So I'm going to use blue for this problem. Number 4 says we want the blue cube to show a 4, and the yellow is the other color. Yeah. So let's say this is yellow, this is blue. I'm just going to label them real quick. Okay, so the lightly shaded is yellow, the darker shaded is blue. I want to find the probability that blue is 4 first. Okay, that's my first event. So if I look at this table, this set right here is when blue is 4. So how many different favorable outcomes is that? 1, 2, 3, 4, 5, 6. So that's 6 out of a total of 36 possible outcomes. So 6 over 36, which does simplify to 1/6. Now, the second part is that we would like the product to be less than 20. Okay, product means we're multiplying. So we are just going to be looking at this set right here for finding the probability of the product less than 20. So multiply less than 20. Well, 1 times 4 is 4. And that is less than 20, so that works. That's 1. 2 times 4 is 8, which is less than 20. So that's a second favorable outcome. 3 times 4 is 12, which is less than 20. So that's a third favorable outcome. 4 times 4 is 16, which is less than 20. So that's a fourth favorable outcome. 5 times 4 is 20. And we only wanted strictly less than. So This is not an option, and 6 times 4 is greater than 20, so that is not an option either. So we only have 4 out of 6 that would work, which does simplify to 2/3. To get the probability of this dependent event occurring, remember we need to multiply these two things together. So that would give me 1/6 times 2/3. Go across the top, across the bottom. That gives me 2/18. 2/18 does simplify. They're both divisible by 2, so your final answer will be 1/9. Okay, number 5, I'm going to use a purple pen this time. Number 5 says we would like the yellow cube to be a multiple of 3, and we would also like the product to be 6. So I'm going to take a look at this table. The first thing I'm going to do is the probability that yellow is a multiple of 3. So those numbers would be like 3, 6, 9, 12, so on and so forth. Okay, here's my yellow cubes. My multiples of 3 would be 3 and 6. So the yellow is 3 in this set right here. And then the yellow is 6 in this set here. So there are 12, because 6 plus 6, favorable outcomes. And that does simplify, so I'm going to go ahead and rewrite it as 1/3. Now we also want the probability that the product is 6. So when it says the product is 6, that means it's exactly equal to 6. So let's take a look at our possible outcomes. So right here and right here, not the whole set, and see how many would give us the product of 6. 3 times 1 is 3, so that doesn't work. 3 times 2 is 6, so that would work. 3 times 3 is 9, 3 times 4 is 12, so on and so forth. Those won't work. Now let's look here. 6 times 1 is 6, 6 times 2 is 12, 6 times 3, 18. So these numbers are going to keep getting larger, so those wouldn't work. So we only have 2 favorable outcomes out of just these 12 that we were looking at. So that would simplify to 1/6. Because these are dependent events, we're going to multiply those together. Going across the top, across the bottom, I got 1/18. Okay. Number 10 is independent events. We're going to be choosing the same activity when 2 friends each randomly choose 1 out of 4 extracurricular activities. So if there are 4 different, I'm going to put probability of, let's say, I don't know, extracurricular number 1. It didn't really say what the options were. And we want them to pick the same one. So there's only 1 that they can select out of 4. And the probability that they're going to select that same one would be 1 out of 4. Multiply that across the top and across the bottom. Your answer is 1/16. Number 11. Rolling an even number and then a 6 when a number cube is rolled twice. So at this example, they're not rolling them at the same time and asking 2 different things to happen. It's saying, hey, I'm going to be rolling and I want it to land on an even number. And after I've rolled, I'm going to roll again and I want it to give me a 6. So that's why it's independent. Now there are 3 out of 6 faces that are even on a traditional number cube. That would be the numbers 2, 4, and 6 out of 1 through 6. And then I'm going to multiply that by 1/6 because there's only 1 6 out of 6 faces on that cube. You could either go across the top and bottom right away, or I do see that 3 over 6 is 1/2. For me, that's just easier to do the math, so I'm just going to go ahead and convert it and then write my final answer as 1/12, which is simplified. Number 12. 12 and 13 are dependent events once again, and we're going to be using a blue and yellow just like what we did before. Okay, I think I'm going to use green and red just to make it easier to go through. So number 12 will actually be green. Okay, I want the probability that the yellow is greater than 5. So here yellow's 1, 2, 3, 4, 5, but that's equal to, I want it to be just greater than. So this is my set right here, these 6. So that means that can happen 6 out of 36 times, which can be simplified. Now, just looking at these 6, I want to know how many would have the product that is greater than 24. So when I multiply, it needs to be larger than 24, not equal to, larger than. So that's the probability product greater than 24, given that this has already happened. So I'm just looking at these. Well, 6 times 1 is 6, which is not greater than 24. 6 times 2 is 12, which is not greater than 24. 6 times 3 is 18. 6 times 4, that is 24, but that's not what I want. It needs to be greater than. So 6 times 5 is 30, which will work. That's 1. 6 times 6 is 36. That also will work. So that means 2 out of 6, or 1/3, for the ratio. Because they're dependent, we're going to multiply these together. So 1/6 times 1/3 gives me 1/18. All right, number 13. We want the probability that the blue is less than 3. So let's look at our table here. When will the blue be less than 3? Well, that would be here, because 1 is less than 3. That would be here, because this has blue being 2, which is less than 3. This is exactly equal to 3, so that wouldn't work, and these are all larger. So just these two sets would work. That's 6 plus 6, or 12 out of 36, which does simplify to 1/3. Now, just looking at these 12, I want to know when the product is 8, how many favorable outcomes would it be? So when it says the product is 8, that means it's equal. So is means equal. 1 times 1 is 1, so that would work. 2 times 1 is 2. That's 3, 4, 5, 6. None of those work, okay? Let's look here. 1 times 2 is 2, so that doesn't work. 2 times 2 is 4, which is not equal to 8. 3 times 2 is 6, which is not equal to 8. 4 times 2, though, that is equal to 8, so that's one favorable outcome. And then this would be 10, and this would be 12. So we only had one favorable outcome out of the 12 that we looked at. So now we need to multiply these together, and that would give me 1/36.